Anyway, I survived and I'm here to talk about CPARs. Okay. Wait, let's try this one. Here we go. Okay, you've seen quite a few diagrams of the food system and how antibiotic resistance moves. This is just another diagram. And basically, the circles describe where antibiotics are used, and the squares are just different settings. And so as you can see from the arrows that go back and forth, is there a pointer up? Yes. So we have the food chain here, which is, obviously moving through abattoirs to retail meats and then to the human population. But we know antimicrobials are used extensively in hospitalized patients, in community extended care facilities, and to treat travelers, etc. Antimicrobials are impregnated into household products and into the hulls of paint used for ships. It's used in fuel ethanol production as well for potable ethanol production. It's certainly used in your pets. And we know obviously is some use in aquaculture as well. And so the opportunity for resistant organisms to move between animals and humans and between the environment through water and is a problem. So this just basically describes what we started to look at when we thought about building a surveillance program. And where did we need to start collecting information at the food animal level, at the human level, or maybe some of these other areas as well. So that was the beginning of the design of CPARs. And when we started, it was back in 1998, so it was after the US NARMS had started. And I say we, but it was me looking around at other systems. I looked at the NARMS system, I looked at what Denmark was doing, and looked basically inwardly at Canada and what information may be available to start from. And at that time, antimicrobial resistance was not considered a food safety issue, so there wasn't any real program that was looking at it. We didn't have any infrastructure for collecting antimicrobial use or antimicrobial resistance along the food chain. Our Canadian Food Inspection Agency, which is the equivalent of the USDA, I guess it's the equivalent of your ACHIPIA, is basically we're not collecting representative samples that we could use for resistance testing. There certainly were residue programs, but we did not see those samples as an opportunity to build an integrated surveillance system. There was reportable salmonella coming in through our OIE reference lab, which meant we could take some of those isolates at least and do susceptibility testing. There was some export tests that we made, but again, we really realized very early on we needed a new approach and a design to build a system in Canada. So this is how it started. So in '97, we had a national consensus conference where we had the human and the veterinarian and the hospitals and the community all come together and decide where we needed to start. And there were 27 recommendations that came out of that conference, and one of them said, what's going on with the animals? Maybe we should look at animals. So that's how the recommendations started coming down. And then, through the early 2000s, there was recommendations that came from the WHO, and then we had an advisory committee also that was reporting into Health Canada that again recommended that we have a surveillance system. So basically, we were building the design aspect here all through these years. I started hiring a few people, some very, very talented minds. And so from an epidemiologic perspective, we designed the program. And we started with abattoir, and we collected in beef cattle and poultry and pigs. And we also had our OIE reference lab for salmonella. So those were the two pieces that we started in 2002. We used the US NARMS methods in terms of their susceptibility testing because we knew there was going to be comparisons between Canada and US in terms of resistance. So we started right from the start in terms of building the same methods there. Then we started in retail meat, only in the provinces of Ontario and Quebec, which are two our most populated provinces, so they have the largest number of people live in those provinces. And then we started collecting human clinical salmonella isolates. So now we have human, retail meat, and abattoir. And then we expanded a little bit farther west to Saskatchewan, which is another province in Canada. And then with new funding, we were able to start on the farm. So we started in swine because there was issues with BSE in cattle and avian influenza, and those two commodities did not want us on the farm at that time. So, but the swine industry was very, very interested in helping us build this. So that was the beginning of that one. Then we moved to add retail meat in British Columbia, and then on the East Coast and Maritimes. We added in some fish and shrimp and produce. Again, it's building on based on the kind of funding that we were able to obtain. And then we started in broiler chickens on the farm level in beginning of 2013. So that's sort of how that built in. Here is where we started collecting our national antimicrobial sales information for use in animals. So that's from the Canadian Animal Health Institute. And there should be another description here, but there's a human use piece that came in here where we started collecting human use as well. So it started to come along as an integrated system. So it's the same objective of any surveillance program, right? You want to monitor trends in resistance and use. You want to be able to disseminate timely results. You want to look at the public health impact from a risk assessment standpoint of antimicrobials used in both humans and animals. And you want to be able to compare what Canada is seeing with other countries that have similar surveillance systems. So these are very important objectives. So this is what CPARS looks like now. We're still only in Salmonella, but we're moving hopefully into Campylobacter soon on the human side. And then we have our sick animal population, so our clinical isolates from sick animals. Then we have the farm piece, abattoir piece, retail meat. And then on the use side, we have human use. We have the farm piece, which is now swine and chicken. And we have the national data that's provided by the Canadian Animal Health Institute, which is the pharmaceutical piece in terms of sales. So I'm going to go through each list here and describe each portion. One of the things that we have used is when we're describing our data, we use this categorization system that was developed by our Veterinary Drugs Directorate at Health Canada. So this is how we categorize 1 through 4. Very high, medium, and low importance, which is the sort of the non-human use antimicrobials, which includes the ionophores. So the very high ones we're more concerned with is these antimicrobials considered of very high importance in human medicine, which include the fluoroquinolones and the third-generation cephalosporins. So we do tend to pay attention to that, and when we're reporting integrated results, that's how we tend to focus a lot of our paragraphs on it. So I'm going to describe a little bit the human piece, the antimicrobial resistance. You heard the National Micro Lab, so that's in Winnipeg, and that's where isolates are sent. So basically, for the antimicrobial resistance, it started in 2003, and all of our provincial public health laboratories ship isolates to the National Micro Lab. Our largest populated provinces send half of the month. So the first 2 weeks of the month, they send all their isolates. And the smaller populated provinces send basically all their isolates received. So the NML then does all the susceptibility testing on those. So in terms of reporting, this is the ones we're focusing on because these are the ones that are most important in human medicine. It's Heidelberg, Antiretidis, Newport, the typhimurium, and as mentioned in Pat's presentation, the 4, 5, 12 I-. We also do typhi, paratyphi A and B. The use piece in the human side is it's sales data that's provided by IMS Health, and this is a marketing firm that sells their data for a price to various places. So we're able to purchase the pharmacy, hospital, and physician data from that company. And then we do a further analysis to basically provide it into a defined daily dose or per prescription or per whatever denominators you want. So that's basically what we're collecting on the human side. And now we've got on the retail meat side, we have samples of chicken, pork, beef, turkey, chicken nuggets, and fish and seafood. And these we just basically are doing on an ad hoc basis. They're not sort of part of our routine piece. So we have people going to retail outlets to collect these samples for us to get in the lab. So all of these packages of retail meats are shipped to our lab in Quebec, and we are collecting generic E. coli, salmonella, and campylobacter from chicken and from turkey, and E. coli and salmonella from pork, and just doing generic E. coli from the ground beef. And so what it looks like right now is we have 7 of our 10 provinces where we have retail food samplers going out and collecting samples across the country. In Ontario and Quebec, these 2 provinces here, we have continuous sampling, so there's sampling going on every week. And then in the smaller populated ones, we're doing them every other week. Again, it's trying to have representative sampling, but also recognizing that you're trying to save money. So then we have the Avatar component, which is our oldest component. It was implemented in the fall of 2002 with 51 plants that are being sampled across the country. We're currently in year 12 of our sampling, and basically it's a fully voluntary program. So the processing plants actually collect the samples for us. We ask for them to collect fecal samples, so we ship them the sampling kits, and they do the sampling for us and ship it back to our lab. So the only thing we're collecting right now is province of origin, of where the animal was raised, and not necessarily where the abattoir is located. And then we do the microbiological data on the isolates. So in terms of fecal sampling, we have generic E. coli, salmonella, and campylobacter, again from chicken and swine, and beef we're just doing generic E. coli. And this is what it looks like. We have basically 100% voluntary. We write them letters every year saying, do you still want to work with us? And they say yes, so that's really good. Then we have our Sentinel Farm, which is our last component that we've been working on. And basically, right now, as I mentioned, we're in market swine and in broiler chickens. And this is our main source for valid antimicrobial use information, because we have a questionnaire that's provided to the producer through our volunteer veterinarians. And so then we can collect this farm level data also on animal disease, animal husbandry, and various issues like that. We also are collecting some samples for antimicrobial resistance testing. This is just a description of the data collection that we do for swine. We try and balance it between winter, summer, and fall sampling across all the different herds. We're only sampling for finisher swine. We have 1 sampling collection per year, per herd. And we have these veterinarians who are the ones that actually do the sampling, and they decide how to distribute it. So it's a random selection. So we have fecal selection, fecal samples collected, and then we have this close to market questionnaire, which basically provides us our antimicrobial use data. And in terms of broiler poultry, it's been going for 1 full year, and right now it's also a Sentinel Farm surveillance. So we have 20 farms in BC, 15 in Alberta, can't really see where we are in Ontario and Quebec, and these are the vets that actually are going out to these farms to do it. So we have 2 vets in BC, 1 here, and several in Ontario, and 4 in Quebec. And then finally, it's the use piece, which, as I mentioned, we get from the Sentinel Farms as well as the Canadian Animal Health Institute. So the Canadian Animal Health Institute represents something like 95% of the manufacturers of antimicrobials that sell antimicrobials in Canada. And they provide us with a kilogram of active ingredient distributed for sale. And there are some missing pieces because in Canada we still allow importation of active pharmaceutical ingredients, and there's also some own use importation that's allowed. So there's a percentage, I think it's up to like 13% of our total data that may be missing here. And then from the active surveillance component, we, as I mentioned, we have sentinel swine since 2006, poultry since 2013. And right now we are doing sort of pilot sentinel systems in turkey, dairy, and beef right now. This is the kind of data that we're getting. So we have whether it was feed, water, or injected, by class, active ingredient, reason for use, frequency, dose. So this is all the data that we have and that we can collect and analyze. This just provides sort of an overall estimate comparing human use to animal use. This is calculated based on the information provided by the Canadian Animal Health Institute. So we estimate in 2013 that 79% of the medically important antimicrobials produced in Canada or distributed for sale in Canada were for use in animals. And so that represents about 3.8 times the use in people. So that just gives a background. We estimate the companion animal use to be about 0.6%. So the important part of having an integrated system is integrated data. And this is not a simple system. The more pieces that you add on, the more times you have to make sure you've got standardized data acquisition. So this is our farm piece, this is our abattoir piece, retail for each of them. Then we've got the passive systems, which is we have some feed pieces we get from CFIA, the diagnostic pieces, human and animal. Then we have, the use piece in animals and humans, and it all has to come together in some sort of standard way so we can integrate and report it. And we're working really hard at trying to figure out how best to do that because it just gets very, very complicated. So we're starting to figure out that we're going to produce our reports in chapters where you've got chapter 1 is methods, chapter 2 is antimicrobial resistance, chapter 3 is antimicrobial use, and chapter 4 is integration, where we're starting to tell the stories, where you grab what's happening in humans, what's happening in animals, what do we know about use, and trying to bring them together. And we're old enough now, with 12 years, that we're starting to be able to tell some stories. So this is one of the stories that you may have heard of. It's related to the use of ceftiofur, which is the third generation cephalosporin used in animals, in food production animals as well as in companion animals. We know it's been used quite extensively in an extra-label drug use manner for prevention of E. coli in poultry, and so that's considered a mass medication. Ceftiofur is very much related. It's the same basic molecule as ceftriaxone, which is a very important antimicrobial for use in humans, and for treatment of invasive salmonella and other severe infections, especially in pregnant women and children. And basically, with a lot of these invasive diseases, resistance to these third-generation cephalosporins in hospitals can lead to having to use one of the last antimicrobial classes that's available, which is the carbapenem antimicrobial. So this is certainly a big concern. Where we see resistance to ceftiofur, we saw it more commonly in this serovar. So Salmonella Heidelberg is like number 1, 2, or 3 in Canadian humans. So it's obviously different than what you see here in Chile. And Heidelberg seemed to have this really nice propensity for picking up this plasmid that was related to ceftiofur resistance. We see it very often in chicken. You can see that retail, abattoir, passive, and then the nuggets. We're seeing up to 40% of the nuggets that have this resistance in Salmonella Heidelberg. We also see it in turkey, and we're just starting and collecting some turkey data, so that's why that's sort of there. We do see the odd one in some of our passive clinical cattle, and then can't even see what it says, horses. We do see it in horses as well. But the propensity is in chickens. So knowing that salmonella is a frequent and important cause of enteric disease in Canada, we've certainly done a lot of investigation on this one. And this is something that we saw in the province of Quebec. We started, as I mentioned, in Quebec in 2002, 2003, collecting retail data chicken. And what we saw at that time is that there was this high level, up to 65% basically, of retail Salmonella heidelbergensis chicken showing resistance to cephalosporin. And it was quite high in humans. When we compared this to the Ontario data, it was way down. So there was something going on in Quebec that we investigated. And we found out that there was in ovo injection of ceftiofur being injected into hatching eggs, again as a preventative, in that province, almost across all hatcheries, and it wasn't going on in Ontario. So there was this linkage. So there was a lot of discussion with the poultry industry in Quebec, and they decided to voluntarily withdraw the use. And we saw this dramatic drop. And then they started going back to using it again because the rest of the country was using it and they didn't want to be left on their own. So they've gone back to use, and then we saw this ratcheting up again. And basically in May of 2014, the chicken industry in Canada has done a full national ban. So that's a very positive piece. So this is how powerful the integrated piece can be in terms of surveillance. And this just basically echoes what Pat said in terms of the value of an integrated system. You know, from a public health perspective, it's incredibly valuable for the attribution pieces, interventions, and there's also pathogen reduction strategies that are going on in Canada for Salmonella, and we have probably some of the best Salmonella trend data that's available in Canada. So we're able to support some of these things. From an animal health perspective, the CPARS data is being used for pre-approval and post-approval monitoring for antimicrobial agents, so part of the approval process for veterinary use. From an international trade perspective, it's considered integral to the Codex framework for risk analysis, so it's going to become more and more important for those risk assessments. And then as a surveillance platform, as I said, we often get researchers saying, hey, have you got some isolates or can we get some samples? So we've done studies with MRSA and C. diff and some of the other non-core food products, just basically because we can collect them. So it's been a very positive experience for those collaborations. So the report's on our website. We're trying to be more timely with that, and hopefully you're getting there. And it's a big team. A lot of people have been added on from starting with 1 and then 3 and then 5 and then 10. And then there are a lot of collaborations where we get in-kind, support from other groups. So across the provinces and public health. Thank you.
Muchas gracias, doctor Irwin, por su presentación. Finalizaremos la sección de presentaciones con